Good afternoon or good morning if you're getting it this early. And if this is good morning to you, good work. If it's Saturday and it's good morning, hey, that's fine too. And if it's Sunday and it's good morning, hey, whatever. You get your Delta Math done. That's good. It's good practice. All right. So I'm gonna turn my mic on, and if you want to listen to the Delta Math walkthrough as I go through it, you're welcome to. Here, even share my screen so you can see the Delta Math. Okay. So let's crush these few problem types here. Very few problem types. Finding future value of an annuity, finding a payment value, um, and then finding a fixed monthly payment on a loan, and finding the maximum amount that you could borrow. Okay, so these are our two different topics today: present value and future value, and two different variables that we're solving for in this course. Okay, you can also solve for the interest rate necessary. You can also solve for the time, but you'll do that later. Okay, go easy on yourself. Just learn how to do these four things today. All right, so our first problem type are finding future value of annuities. So let's get all the junk out of the way of my screen and let's get some paper open. We're going to clear the paper and make it smaller so that I can see the question. All right, so Kayla, we're talking about Kayla today. That sounds great. Kayla, what are you up to? Kayla is she's depositing a real chunk of change every month. Her regular payment here, let me get this up just a little bit. Okay, that's better. All right. Her R, which is a regular payment amount, is $520 per month. Good for you, Kayla, saving a real significant chunk of change every month. At an interest rate of this is a percentage, even though it doesn't look like a percentage, it is, because that's the monthly interest rate. So remember, Delta Math is already doing that divide by 12 for you. So this is this times 12 is what she's earning as a percent. So that's 3 points, about 4%, I think, divided by 12. Okay, so anyway, maybe it's exactly 4%. All right, so that's not. Yeah, so I here is the interest that's going to go into the formula. D is R. They're using D for their formula. I use R, so who cares? Okay, and I is 0.00375. That's as a decimal. I added 2 zeros to move the decimal place twice. And then N is 6 years per month. So N is equal to 6 times 12, which is 72. Cool. Okay, let's go. Let's go, folks. So we want to know how much money she's going to have after 6 years of depositing this real chunk of change. Okay, so let's do it. Future value is equal to the regular deposit multiplied by 1 minus, yeah, 1 plus I to the n minus 1. Okay, 1 plus I to the n minus 1 all over I. Okay, let's do it. R is 520. 1 plus I is 1.00375 raised to the power 72. That is a 7. Okay. Minus 1. All divided by 0.00375. Well, that's exciting, dividing by that really small number. And then we calculate. Move this, and then we move this. And then we can see everything, and we calculate 520 times first bracket 1.00375. I didn't like this calculator before, but I'm getting used to it, and I sort of don't mind it now. To the 72 minus 1 end bracket divide by, see, that's not a lot of money, but I divide by 0.00375. And that equals, a real amount of money. So in 6 years, Kayla was going to have about $43,000. That's really cool. It's really cool. Okay, so how much money does she have to the nearest dollar? Okay, so I'm going to grab this number, which is to the nearest dollar. I'm going to paste it in here. Remove the comma. I'm going to say, yes, I'm sure. And it says, yes, you are correct. you did everything right. So this is the number of dollars per month. This is the interest rate per month. See, there's a couple zeros. Convert years to months. We say this is time T times C, which is compounding periods per year. I think that's a nicer way to understand it. And then plug everything in. Evaluate top. Divide. Blah, 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 blah. Done. Okay, so let's take a look at one is enough. Okay, we'll do another question here, different one. Now we're trying to find the payment amount. Okay, so now we're trying to find what they call D and what we call R. All right, so let's write down what we have. Well, Jackson, you're saving money and you're going to make annual contributions. Very good, very wise. And you would like to have $9,000 after 9 years. So you could put $1,000 a year into your mattress, Jackson. Or you could follow the advice and get a really good interest rate there. It's compounded annually, 8%, really good. So you're going to actually save yourself some money. You won't need $1,000 a month. $1,000 a year. My guess it's going to be $700 a year. I'm going to say it's about 70%. We're going to increase your money by about half in 9 years. I think. Let's see. Let's see if I'm right. Okay, my estimates are pretty wild in here, so we'll see. So we know that I is just the interest rate. It's 0.082. Okay, that's there. The future value that's desired is $9,000. And the N, the number of years, is 9. Okay, we have a C of 1. Okay, so because we have a C of 1, the interest rate is the I, and the number of years is the N. Okay, so let's plug it in. Okay, so we have here future value is equal to the regular payment amount, which is what we're trying to find, right? How much does Jackson need to save every month? Okay, future value is R multiplied by 1 plus I raised to the power N minus 1, all divided by I. So let's rearrange the formula so that it is I multiplied by future value, all divided by 1 plus I to the N minus 1. And that's equal to R. All right, let's plug in here. Okay, we know that I, 0.082 times the future value desired. Jackson needs $9,000. Jackson, you can reply to this video and tell us why you need this $9,000 in 9 years. It's oddly specific. Okay, and then 1 plus I to the N is 1.082 to the 9 minus 1. All right, and that's how much, Jackson, you're going to need to save per year to have $9,000 in 9 years, earning 8.2% interest. Why didn't they just make it 9% interest? And we could have had a lot of nines in this question. That would have been super cool. Maybe it's not cool. Okay, so let's do it. Okay, clear everything. All right, 0.082 times $9,000 equals that amount of money divided by, which was very close to my, divided by brackets 1.082 raised to the power 9 minus 1. Oh yeah, it's cool, it's good. And bracket equals. Very good, Mr. Jennings. Your guess was really good, eh? $700. Wow. I'm just tickled that my guess was so good. Okay, let's copy that. And it feels totally reasonable, right? Like if you're getting a little help from interest, actually this is a lot of help from interest. That's a good interest rate. If you're getting a good amount of help from interest and you want to save $9,000 in 9 years, you should be paying a little less than $1,000 per year. And the difference, the amount less that you pay, is the help you're getting from interest. Okay, so we're very happy with that. We put that in, we round to the nearest dollar. So this goes away, it becomes 5. Enter, enter, yay! So that's how you do that type of question. Find a monthly payment on a loan. Okay, so now we got different formulas. All right, let's do it. Now it's Jason. Okay, Jason, what are you up to? All right, so pull this over. Okay, he needs to take out a mortgage. Okay, and this is after he pays his down payment on his house, right? Of $500,000, which buys you surprisingly little in Collingwood. Yeah, these days real estate is crazy. Hopefully, it's easier to enter the market when you're entering the market to buy a home. Cheers to all of you. Start saving now. Put a nice down payment together and everything's easier. Okay, so save. Save. You're young. Save. Okay, I've said it before. I'll say it again. Life moves pretty fast. If you don't stop and save once in a while, you could miss it. Okay, and if you get my references, wow, I'm impressed. Okay, so present value is equal to the regular payment multiplied by this? Really? Huh? Using the formula below, using the monthly payment? Oh, this is the monthly payment. Okay. All right. So they've got their thing solved for a monthly payment already. Now let's take a look at our formula, see what we would use. Okay, am I still there? Yes, I'm still there. No, log me in. I want to see these things. Okay, so present value of an annuity. So we have this formula. I want to use our formula instead of their formula. Okay, why do I want to do that? Because I'm a little stubborn. Okay, so present value is equal to R multiplied by 1 minus 1 plus I to the negative n, all divided by I. Okay, cool. Now let's go for it. So now what am I doing? Okay, so I'm going to plug things in. I got to go get my numbers. Okay, an annual interest rate of 5.4% compounded monthly. Oof. That's really high for a mortgage. Jason, I'm sorry, you're buying at the wrong time, man. You got to get yourself a better rate than that. Determine his payment to the nearest dollar if the loan is taken over. He's going to pay this back fast. Oh, man. I think he's got to pay like $6,000, $7,000. I think it's less than $10,000 a month, but it's pretty close, I think. Let's see what it works out to with our formula. All right, so I know this is PV is equal to that. I is equal to this compounded monthly, so 5.4% divided by 12. N is 12 times 10, okay? And I want that as a decimal. And I see that this has a factor 0.3, so it will not create a repeating decimal. It will be nice. 54 does not go into 12 evenly, but it is half, so that would be, let's do this one mental math, and I'm just going to pause and do mental math. So, okay, 54 divided by 12 is 4.5, so this will be 0.45, so let's do that correctly. So this will be 0.45%. We've got all our numbers? Yeah, so this is equal to 0.0045. Okay, prove it to you. 5.4 divided by 12 equals 0.45. So, like I said. All right, and then n is 120. Okay. All right, so now let's plug and chug. So again, I'm going to do this thing where I take this and flip it with its reciprocal and put it over there. So I'm going to have R is equal to I, which was on the bottom, so now it went over there and became the top. And then I wrote that over there just to confuse you. No, not to confuse you, just because it's easier for me, okay? 1 minus 1 plus I raised to the power negative n. Raised to the power negative n? Lowered to the power negative n? I don't know how we say that. Raised to the power negative n is how you say that. Okay. Let's do it. Let's plug and chug. So just going to zoom out so I can see the numbers and give myself more space. All right. The annual payment, R, is equal to the interest rate, which is 0.0045. Well, that's nice. I get to multiply my payment by that, which is a small number. But then I multiply by this ginormous number. Divide the whole thing by 1 minus 1.0045. Notice how I skip a step and I don't write 1 plus 0.0045. Raised to the power negative 120. Okay, let's go for it. All right. So punch and chunch. Wait, plug and chug. Punch and chunch. I don't know what that means. Plug and chug, please, people. Clear, clear, clear. 0.0045 times 520,000. And if you're tired of writing all those zeros, you can cancel some zeros before you do this multiplication. Divide by bracket 1 minus 1.0045 raised to the power 120, but it's not 120, it's negative 120 equals, oh, well, would you look at that? He only has to pay 5.6 grand per year. And I said it's going to be less than 10 grand, but it's going to be close. Well, at least I was in the neighborhood, but I'm surprised he has to pay so little, given that he pays so much interest and he's paying this down so quickly in 10 years. In Canada, that's usually 25 or 30 years that people will take to pay their mortgages. And they're happy. People are happy. Like people like myself are happy to pay their mortgage over that much time because our interest rates are low right now, historically low. The pandemic has lowered interest rates. So you can find interest rates of like 2% on your house. And then you would just take as much time as you want to pay that because the interest is so slow. And then any extra money you have, you're not looking to like jack up your payments to pay it quicker. What you do is you take the extra money and you invest it and you find a place where you can earn more than 2%. And as I've said, like somewhere between 6 and 12%, and you're like in business, you're making good change. So find yourself these opportunities, people. Okay, so there we go. And that is equal to this number. And I think we were asked to the nearest dollar or to the nearest $100. Let's see. To the nearest dollar. So let's plug it in. Boop. The comma goes away. It becomes an 8. Yay, our formula works. Their formula would also work. Cool. Okay, so that's how you do those types. And then last one. Find maximum amount borrowed on the loan. Okay, so I'm going to use our formula. And here we go. This formula is what we need. Okay, and Sydney is looking to take out a 20-year mortgage from the bank, offering a monthly interest rate of, okay, that's 6%. That's still super high, man. Wow, these interest rates that they're giving here are really tough. I'd be interested to know when these problems were created because interest rates are historical. They do go up and down, and these are all really high. Anyway, we're going to determine the maximum amount she can borrow if she can afford to pay $2,125 a month on her house. Okay, so let's do it. I'm just going to clear the, over here, clear the canvas. Boop. Okay, and then start again. So here we go. So we know that her regular payment, I call that, they have PR. Oh, no, they have a new formula that's already isolated for M, the monthly payment, but we call that R, the regular payment. Okay, you can call it whatever you want. Is she can afford 2,125. Okay, the interest rate is equal to, it's already been solved for us, 0.0045 per month. The N is 20 years times monthly. So 20 times 12 is 240. Okay, there's our numbers. And we want to find what's the present value? Like what can she borrow now if she can afford to pay that for 20 years at that interest rate? Okay, let's find it. So present value is equal to the regular payment multiplied by 1 plus I raised to the power negative n. Google it if you forget. Okay, present value. 1 plus I to the negative n. Yeah, 1 minus this. Okay, so let's write it. Okay, boop. Oh, oops. Okay, here. All right. 1 minus 1 plus I to the negative n, all divided by I. Verify your formulas, folks. Looks good. So let's solve and find what she can afford. Present value is equal to the regular payment 2125 multiplied by 1 minus 1.0045 raised to the power 240, but it's negative, all divided by 0.0045. Right. Okay, just want to make sure that is indeed the negative exponent. Yes, it is. It's definitely a negative exponent. So let's go, people. Let's go. Let's calculate. I have an appetite for some calculation here. I'm going to use my new friend, former enemy, this calculator. 2125 multiplied by bracket 1 minus 1.0045 raised to the power negative 240, and the bracket, that's what's inside the bracket. When I push divide by, that's what's on top of the equation, and I divide that by this. So that's good news. You can afford to borrow more money than $1,400. I'm already dividing, so I just type in that number, 0.0045 equals, okay, she can afford to borrow $311,468.68. Grab this number, copy it, put it into, not Desmos, into Delta Math. We want to the nearest dollar. So that's going to become a 9. This goes away. This goes away. We submit the answer. Hooray! It's such a big number, and it's still like a 1, and we get it right, and we feel very happy, especially since we're using a different formula in there. Now, I could use these formulas. I'm sure they work too, but they're rearranged in some funky way that doesn't have a negative exponent. And during the lesson, I said, you just do it with the negative exponent. But if you don't like negative exponents, you can use this formula. This looks a lot uglier to me, though, than our formula, just dividing by I. Or, well, we would just have an I there. Anyway, they've multiplied by things to then factor out the negative exponent. And I think it's ugly. So there you go. Use our formulas, people. Okay, so that's it. Any problems, any questions, come find me and ask me.